This is 3.1, Relations and Functions. There's a lot of definitions on this section, and it's a two-part video, so just be sure you watch the second part as well. The second part has a lot of examples to it. All right, this first part is a relation. You guys have seen relations all the time. It says it's a set of ordered pairs. So, and a lot of times you guys see it, it's in like an XY chart. And these are a bunch of ordered pairs. Ordered pairs are, it's a point. And it's called ordered pair because the point, the X comes first and then the Y, and that has to be in that order. So a set of ordered pairs, just like this is the point 111, that's the point 212, 313, 413, 513. All right, that's the set of ordered pairs. So this is a relation. So again, that's the definition of relation. A function is a relation where each input has only one output. So when and again, your input is your x's. And so when you put in an x, then out comes one number. When you put in a number, 2, then out comes one number. When you put in 3, out comes one number. When you put in 4, out comes one number. When you put in 5, out comes one number. So that is a function. And a lot of times you guys, let me give you an example of a function, a simple one that looks like that. And a lot of times we make an XY chart, and if we substitute numbers in for the X, so if I substitute -4, if I put -4 right here, well, -4 plus 1 is -3. Notice I put in, it's the input, I put in -4, and then what comes out is, that's the output. In this case, it's -3, and of course, this makes a point. And of course, we can put in another number, 0, and then 0 plus 1 is 1. See, the output comes out. And so that's what it means. When I substitute one number in, only one number is going to come out, and that makes a function. And again, we got the domain and the range. I've already talked about that. And again, the range is the set of outputs. I've already said it several times, but the domain is the set of inputs. So again, I've already said it several times, but it's there. All right, so the domain, again, is a set of inputs. So remember set notation, you put braces, and then look at your input column, 1, 2, 3, 4, 5, and that's what I put there, and then close your brace. And then the same thing with the range, that's the same thing as your output. So your output is 11, 12, and 13. And notice the 13 appears several times in the XY chart, but I only want distinct numbers, and that should be a brace right there as well. So 11, 12, and 13 are the range of that function. So let's look at an example again. If I had this XY chart, and again, this is a relation because I have a bunch of ordered pairs. So this is a relation, and we have to identify the domain and range. It's also a function because every input has one output. So when I substitute 3, I get 1. When I substitute 4, I get 2. Substitute 5, I get 3. When I substitute 6, I get 4. So this is a function. It's a relation, but it's also a function. So the domain of this, remember the domain is the set of input. So look at your inputs. So the input would be 2, 3, 4, 5, and 6. The range is the set of output. This is your output. So 0, 1, 2, 3, 4. And same thing here. The domain and the range would be the exact same thing. We got the domain braces because it's a set of numbers. So -3, -1, 1, 3, 4, and then the set for the range 1, 3, -2, 2, and 6. That's identifying the domain and the range. All right, now another definition first we have the definition of a relation, and then we have the definition of a function, and now we have a more specific type of function. A function is one-to-one if no two terms of the domain map to the same element in the range. Now, first of all, I need to explain the word map. Map is, this looks like an XY chart, and that's really what it is. And I did that on the previous slide. I literally drew some arrows here. See, 2, when I put 2 in, it maps to 0, and that makes the point to 0. When I put 3 in, then it maps to the point 1. And that's really what I'm doing here. This is just a set of points. So like 3, 5, that's what that is. It's a set. When I put, remember, this is my input. When I input 3, then 5 comes out. And so it literally maps to it. And when I put 4 in, it maps to 8. When I put 5, it maps to 9. When I put 7 in, it maps to 12. So a function is one-to-one. So this is a relation because it's a set of ordered pairs. Okay, it's a set of ordered pairs. But it's also a function because every input has one output. 3 goes to 5, 4 goes to 8, 5 goes to 9, 7 goes to 12. And this is also one-to-one because no two term elements in the domain map to the same element in the range. So like every one goes to a distinct one over here. So let's look at this other example. Again, this is a relation. So 3 goes to 5. So that's a point. 4 goes to 5. That's a point. 5 goes to 8. That's a point. And then 7 goes to 9. That's a point. But notice, and this is a function as well, because every point, like if I put in 3, it goes to one number. If I put in 4, it goes to one number. So this is a function. Now, but it's not one-to-one. One-to-one says there's no two terms of the domain. Remember, this is your domain, this is your range. There's no two elements of the domain that goes to just one single number. And there's 2 elements of the domain that goes to one single number here. And you can see it right here. When I put in 3, I get 5. When I put in 4, I got 5 as well. So it's not one-to-one. One-to-one literally means one number of the x goes to one number of the y. That's what that one-to-one means. So is this a relation? Is this relation a function? So again, that's what I'm asking you, is it a function? If it is a function, is it one-to-one? So let's talk about this for a second. Is this relation a function? Well, these are relations because again, we got points. 2, 4 is a point. 3, 5 is a point. 3, 6 is a point. And 8, 9 is a point. So it is a bunch of ordered pairs. So it is a relation. Now, is it a function? A function says, does each input, your domain, your input, does each one go to only one number? Well, notice this right here, 3 goes to 2 different numbers. That's impossible. So if I plug in 3, I should only get one output. So this is not a function. And obviously, if it's not a function, it can't be one-to-one. All right, so this next one, again, this is a relation because you have -4, 2, you have 8, 10, and you have 2, 10. So it's a set of ordered pairs. So this is a relation. Now, is it a function? Function means, again, does each number of the input, this is your input or your domain, does each one go to one number? So when I put 4 in, does it go to one number? Yes, it does. When I put 8 in, does it go to one number? Yes, it does. When I put 2 in, does it go to one number? Yes, it is. So yes, it is a function. Yes, function. Now, is it one-to-one? Well, no, it's not one-to-one because one-to-one means each of the domains go to one number, and it doesn't. So you're having 2 domains go to one output, and so it's not one-to-one. So not one-to-one. All right, another 2 definitions is continuous and discrete. The domain is continuous when it includes all real numbers. So continuous means like it continually keeps going. Think of it like you doing a job, like you go out and raking the leaves. If you continually rake the leaves, like you keep raking the leaves, you don't take a break, you don't look at your phone. You don't take a drink of water. You continually, nonstop, you keep raking the leaves. So that's what continuous means. It does not stop. Now, discrete is when it consists of just, there's a lot of breaks in there. You know, you might look at your phone, you might take a drink of water, you might go inside and rest, you know, whatever. But discrete is, it does not, it's not continuous. It does not include the fractions and the decimals. It literally just includes the whole numbers. So like 1, 2, 3. See, it just includes those numbers. Or 0 and -1. That's -1. That's -2. That's -3. That's -4. So notice it's not continuous, and that makes it discrete. So here's a problem that kind of combines all that together. So identify the domain. So you're looking at this graph. So look at this graph. I want you to identify the domain and the range of this relation. Well, it is a relation. So if you started copying all the points down, so this point right here is -4, -2. This point right here is -2, 2. -2, 1. -1, 0. 3, 1, and then 3, -2. So notice it is a bunch of ordered pairs, so it is a relation. So it says identify the domain and the range. Well, the domain, remember, is a set of all the inputs, all the x's. So we have -4, -2, and all I'm doing is looking at all the x's right here. And I don't want to repeat any numbers. So that would be the set of domain. The range, again, braces. And the braces is the set of output. The y's. And so we have -2, 2, 1, and 0. Remember, you don't want to repeat the numbers. Now, the map of it is literally just, you have basically the set of domain and the set of range, and then you map them. So here's -4, -2, -1, 3, -2, 2, 1, 0. It's these numbers that I'm putting in here. Okay, that's what I'm doing. And then you literally map them. So -4, and this is where I go back and look at my points here. -4 it maps to -2. -2, look at this one, the -2 goes to 2. -2 also goes to 1. -1 goes to 0. 3 goes to 1. And 3 goes to -2. So we mapped it. All right, so is it a function? Well, remember, a function means when I put something, a number into the domain, this is your domain, did I only get one number out? And you can see that it's definitely not, like when I put -2 in, notice it goes to 2 different numbers. So no, it is not, say no, it's not a function. And you could say, why not? It's a function. Well, when you substitute -2 in, you get 2 outputs. The same thing with +3. +3 went to 2 different numbers as well. So you could use either one of those as your no answer. And then it says, if so, is it 1-to-1? Well, obviously, if it's not a function, it can't be 1-to-1 function. So we don't even have to answer that last question to do that. This is part 1 of this is a 2-part video of covering relations and functions. So be sure you click on the second